Alright, this is my first attempt at doing these videos, so let's see if this works. If it doesn't, we spent a lot of money for nothing. But anyway, we just did the centripetal lab right here, and of course, as I said yesterday in class, these are the 5 things that are due on that particular subject. You should have the data already done in class. If not, you're going to be doing that probably out of class sometime. But these two are what I'm about to show you how to do on Excel pretty easily, actually. And these two, I'll actually probably have a follow-up video tomorrow on exactly what I'm looking for on those two particular videos. But let's look at this right here. Okay, this is just a regular paint program. If this doesn't work, you just let me know. This is the equation, of course, that we've been dealing with. I showed you how to do that in class. I can even throw up another video to show that a little bit clearer if that's what you're looking for. But this is the equation that we're going to be looking at. So, of course, you in class in the lab, you had, so you would have had VT versus M2. You had to do VT versus R and VT versus M1. I'm just going to show you how to do these with some sample data right here. Okay, so when you go over here to my Excel program, as a matter of fact, this isn't Excel. This is what's known as Open Office. You can get this online for free if you don't have Excel. It works almost exactly the same way. If you prefer to use Excel, it'll work just fine. It actually does the exact same things here. The symbols might look a little bit different, but it's still going to work. So what we have here is we have some sample data that I've taken in a lab. You have times here for differing mass 2s. As I said before, I'm just going to do the first trial here. So I'm going to be measuring VT through the use of time and distance, and I have mass 2s here. These are of course just sample mass 2s. I didn't actually take any data here, so my data will turn out perfectly, which is nice because I didn't do it in real life. But I wanted to use this opportunity to show you just a few things about Excel that'll make your life easier. For example, see how here how this is 0.05 and 0.075. The computer can notice that these two are of course increasing by 0.025, and so if you highlight both of them, shoot, there we go. Highlight both of them here, and click this bottom right corner, this box right here, and pull down. It will continue that particular trend, go up by 0.25, which is nice if you for some reason need to make a series of numbers or something like that. And of course, like here, these two were both held constant in the lab, so I have those two numbers exactly the same, and pull down, and they just fill out this very, very nicely. Next thing I wanted to show you is this. Excel can make your calculations of meaningless things fairly simple. Like for example, circumference, which of course, as you remember, of course, is just going to be circumference. It's just going to be 2 pi r. I don't know what's up with that particular 2 there. And in our particular case, 2 pi r times however many times you went around. So in my particular case, I'm going to go with 15. Because went around once, then twice, and then 15 total times. So that's the total distance that it went. So I'm going to use my Excel program here. And what you got to do when you're telling Excel that it's going to do a calculation, the first thing you do is you hit the equal sign, and then you just fill it out. You go 2. For Excel, you hit pi for pi, open parentheses, close parentheses, times, and now you'll notice, well, actually in this case my radius isn't going to change, but it might in the future. If I click this box here, okay, it'll use whatever's here. Now when I pull this down in just a moment, it will use these consecutive numbers, which obviously they're not changing, but if they were, like we'll use in just a second, it'd be even nicer. So 2 pi r, because that's my r, times my 15, because it's going to go around 15 times. And my total distance is 47.12, yada yada yada, so on and so forth. You'll notice up here that this is kind of a formatting thing that I've just gotten used to for myself, but it's extremely nice so you don't lose track of what numbers are. Always label what it is and put the units so that you don't, a lot of times a lot of people have made mistakes in labs because they just simple things like make that grams and don't ever realize because they never labeled it. But going back over here, this is going to be of course 47.12 meters. Now, I want this to calculate the exact same thing for these continuing radiuses, so just like I did before, I'm going to take the bottom right portion of the box, and my thing's doing, there we go, okay, and pull that down, and it should be the exact same number, because it's the same radius, and it's going around the same number of times. But now I'm going to calculate my velocity total, Saying equals. Velocity, of course, is distance divided by time, so I'm going to go distance and divide by my times here are in fact going to be different. So here's my distance in meters per second. And this, of course, since my times are going down, my velocity should go up. And I'm just doing this 5 times, but I just knocked out my velocities very quick. Now we're going to graph. In order to graph, okay, we come up here to chart. I believe on Excel it says chart wizard, but ours is it just says chart on OpenOffice. Always use XY scatter. Okay, and it's just going to be the first one there. Okay, then you go next. Alright, now, I don't know about this particular program. I haven't used it a whole lot. However, I can tell you that Excel, if that's what you're using, always assumes it knows what the heck you're talking about, and it really doesn't. So, what we're going to do here is find, maybe not. Hold on a second. Chart type, series. Here we are. Okay. So you're not going to want to use, on your Excel, like I said, it's just slightly different. Data series. I'm going to come here to X values. Choose a range for X values. My particular X in this case, because we're changing M2, is going to be M2. Get it to full. To find X values. Here we are. Now for my Y values, I'm going to pull those. As you can see, my OpenOffice thinks it knows what the heck it wants. Well, actually it does. How about that? It was right. But I just got rid of it. So let's go here. Maybe T. And then I'm going to go next. And the final thing is I'm going to fill in my my labels here. My title, as we discussed with with these before, should just be dependent variable versus independent variable. So this will be velocity total versus the M2. And then on my x-axis I'm going to have, that's my dependent, so that's my M2, which is going to be in kilograms. My y-axis is going to be VT, which is going to be in meters per second. And that's all I really need. So now I'm just going to finish. And here's my graph. Now, you'll notice that this is supposed to be an x squared function if we look at our graph right over here. Because if we have VT here, which it should be, should have put that there earlier. This, of course, is my y, and my M2 is underneath the square root. And k should be, of course, whatever's left over here taken to the square root. This should be a square root function, and it's pretty darn close. However, the one thing that's left out here that's making this, I mean, you can almost see it's like a straight line, but I imagine if we show 0 pretty quick here, if we add 0 into this, we are going to we're going to find that it is very much a square root function. So I'm just going to move the whole thing down. Let's copy and nope. Let's try the first time. Go. Put zeros here. And then when I come back to the chart, I'm going to, let's see here. Let's refine the data. I apologize, I'm not quite as used to this one as I am the other, as I am Excel. But let's see. I can say right now, let's go to data here. Still not doing it. Well, I'm gonna have to start this over and fix this. Dang it.